Look at this mock exam paper. It features a classic, time-consuming math problem. A boy travels to school at 40 kilometers per hour and arrives 2 hours early. If he travels at 30 kilometers per hour, he arrives 1 hour early. Find the distance. Solving this problem with traditional algebra involves setting up fractional equations, finding common denominators, and isolating the variables. In a time-testing environment, that process often requires 2 or 3 minutes of manual work. We are going to bypass that entire process. There is a single master formula that calculates the answer directly without needing to construct a variable-heavy equation. In competitive exams, you are fighting the clock as much as the test itself. Saving 90 seconds on a single question provides the time necessary to successfully complete the rest of the section. Here is the problem text again. We pull the two speeds from the prompt. We have 40 kilometers per hour and 30 kilometers per hour. Let's label the first speed S1, which is 40. The second speed is S2, which is 30. Next, we need the time difference between these two scenarios. We will refer to this as delta t. This chart shows how to determine the time gap. If the problem provides opposite states, like arriving early one day and late the next, you add the times together. If the states match, meaning both are early or both are late, you subtract them. In our example, the boy is 2 hours early on the first trip and 1 hour early on the second. Since both states are early, we subtract. 2 minus 1 gives us a delta t of exactly 1 hour. Watch the units carefully here. If the test gives you the early or late times in minutes, you must divide by 60 to convert them into hours before moving to the next step. Once you have S1, S2, and a time difference in hours, the setup is complete. You have reduced a word problem into 3 confirmed numbers. This is the master formula for distance. We take the product of the two speeds, divide by their difference, and multiply the result by delta t. First, find the product of S1 and S2. 40 multiplied by 30 gives us 1200. Now for the denominator. Calculate the difference between the two speeds. 40 minus 30 equals 10. Finally, multiply that fraction by our calculated time difference, which is 1. 1200 divided by 10 is 120. Multiplying by 1 maintains that value. The final distance to the school is 120 kilometers. There are no complex fractions to balance or variables to move across an equal sign. You are just multiplying and subtracting whole numbers. By utilizing this formula, the process becomes a matter of simple arithmetic. This reduces the time needed for calculation, and it lowers the chance of errors common in multi-step algebra. Some exam questions will require additional steps. Instead of just asking for the distance, they may ask for the boy's actual normal speed, the speed required to arrive exactly on time. We start with the distance we just found, 120 kilometers. Dividing that by the initial speed of 40 kilometers per hour shows that the first trip took 3 hours. The prompt says that traveling at 40 kilometers per hour made the boy 2 hours early. If he arrived in 3 hours but was 2 hours early, his intended travel time was 5 hours. To find the normal speed, divide the 120-kilometer distance by that 5-hour normal time. This results in a final speed of 24 kilometers per hour. The distance calculated via the master formula allows for the derivation of every other value. Once you have the distance, finding the normal time or normal speed is a matter of simple division. This comparison shows the difference in complexity. The traditional method on the left requires balancing equations, while the shortcut on the right uses a fixed structure to reach the answer immediately. To use this method, identify the speeds, apply the time subtraction rule, and execute the final formula. Pull up a few previous exam papers today and test this method against your previous approach on these early-late problems. Performing well on these tests is not just about solving the math, it is about using efficient methods to manage your time under pressure.